Hello and welcome to today's video on using inscribed angles and polygons. I'm pretty excited about today's joke. What do you call a teapot of boiling water on top of Mount Everest? What do you call a teapot of boiling water on top of Mount Everest? Right, we will come back to that. You won't want to miss it. Alright, so let's get started. A few definitions first. 10.4 in our book, use inscribed angles and polygons. Still relating around circles. Okay. So first of all, if I have a circle and if I have what is an inscribed angle, it's an inscribed angle. Would this be this guy here? And it has its vertex is on the circle, and then those part of the sides of the angle are made up of chords of the circle. And this arc we call the intercepted arc. And it has its endpoints on the sides of the angle. And there's a cool relationship here between the measure of this angle and the measure of this arc. And there's a theorem in our book, but let me just draw this out in a picture versus writing it out in words. Okay, so if I have a circle, call it circle C, and call this A, B, and D. The measure of the angle here, the measure of angle A, D, B, this angle measure, is exactly half of the measure of arc, intercepted arc AB. Okay, so if this is 50, this is 100. If this is 80, this is 40. Okay, this angle is half the arc. So let's take a look at, there's just a kind of a cool problem that has us explore that a little bit and what we can find out from a circle. So if I use this diagram, I'm going to ask you two questions about this one. Okay, we'll call it circle P. T and R, and a Q up here, S here. And let's say, and I'm going to draw a chord in here. Okay, I know that arc RS has a measure of 48, and I know that angle QRT has a measure of 50. So let's look at two different. I think I need to take my earring out because it's clicking, and it's going to make noise. Sorry. There we go. So problem A, measure of angle T is what? How do we figure out the measure of angle T? Well, measure of angle T is half the measure of arc RS. So it's half of 48 or 24 degrees. Okay? Then let's say the next question I want to ask you about is I want to figure out the measure of arc QR. Well, I can see here that TR is a diameter. So arc TQR is a semicircle. And I don't know arc QR. I don't have an inscribed angle for that, but I have an inscribed angle for arc TQ. So let's just find arc TQ first. That's equal to double the inscribed angle. So it's going to be 2 times 50 degrees, or 100 degrees. So if this is 100, QR, measure of QR, has to be 80, because the whole thing is a semicircle. Alright, let's take a look at another theorem. And then again, today's notes, I'm not writing out the theorems in all the words. I'm just kind of describing them with a picture, which for me is more helpful in this lesson. If two inscribed angles pair up with the same intercepted arc, they're congruent. Makes sense, right? Because AB is reflexive to itself. So if this is 100, this is 50, and so is this, because they both have the same intercepted arc. So let's just draw. I'm just going to draw one more example here with a couple numbers. Same kind of scenario. If this is 120, then this guy has to be 60 because of the theorem that we just looked at, and then they would be congruent because they have the same intercepted arc. Let's talk about another vocabulary item that comes up in this lesson. inscribed polygons. So inscribed polygons have their vertices on the circle. So this would be an inscribed triangle. Or you could have an inscribed quadrilateral. You could have any number of inscribed polygons. But all the vertices would have to be on the circle itself. And there's a couple cool things that we can learn about those inscribed polygons. Oh, and there was one other vocabulary item. These circles then are called circumscribed circles. Okay. Another theorem that's introduced here, and I might read this one right from the book. Again, I'm not going to write all the words down, but in this scenario, if we kind of get more specific on this triangle, if we put a right triangle in a circle and inscribe it in a circle, the hypotenuse and the diameter are always going to be the same thing. Our book tells us if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. And then conversely, right, I don't want to say it wrong. Conversely, if one side of an inscribed triangle is a diameter of the circle, so if we don't know it's a right triangle, but we know it's inscribed and it's one side is the diameter, then we know it's a right triangle. And we know that the angle opposite the hypotenuse or opposite the diameter is the right angle. So that's going to come up a lot in problems as you practice, that you have to recognize that that's a right triangle. If it's inscribed and if this is the diameter, then it's a right triangle. And one other theorem, and something that you're going to have to practice as part of this chapter is, or this lesson, is that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So that is going to be another thing that we'll practice solving for missing angle measures in this quadrilateral. So I'll just call this 1, 2, 3, and 4. If this is inscribed, if every vertex is on the circle, if it's inscribed, then angle 1 and angle 3 are supplementary, and angle 2 and angle 4 are supplementary. Okay, so if let's say I'm given a drawing, and we'll look at all kind of different drawings in class. Let's say I know this is 80 and this is 75. And I have x and y there, then I know these opposite, if it's inscribed, which it is, then those have to add up to 180. So x is 100 and y is 105. Oh, back to the joke. What do you call a teapot of boiling water on top of Mount Everest? A high pot in use.